Chapter 3 Summary. Message formatting and encapsulation. Example: personal letter contains the following elements: identifier of the recipient's location, identifier of the sender's location, salutation or greeting, recipient identifier, the message content, source identifier, and end of message indicator. Message size. An overview of segmenting process. The size restrictions of frames require the source host to break a long message into individual pieces or segments that meet both the minimum and maximum size requirements. Each segment is encapsulated in a separate frame with the address information and is sent over the network. At the receiving host, the message are encapsulated and put back together to be processed and interpreted. Message timing has access method, flow control, and response timeout. Network protocols. How the message is formatted or structured. The process by which networking devices share information about pathways with other networks. How and when error and systems messages are passed between devices. The setup and termination of data transfer sessions. Interaction of protocols. Application protocol has Hypertext Transfer Protocol or HTTP. Transport Protocol is a Transmission Control Protocol or TCP. Internet Protocol is also Internet Protocol or IP. Network Access Protocols is the data link and physical layers. Creation of Internet. Development of TCP or IP. The first packet switching network or predecessor to today's Internet was the Advanced Research Project Agency Network or ARPA NET, which came to life in 1969 by connecting mainframe computers at 4 locations. ARPANET was funded by the U.S. Department of Defense for use by universities and research laboratories. Bolt, Beranek, and Newman, or BBN, was the contractor that did much of the initial development of the ARPANET, including creating the first router known as an Interface Message Processor or IMP. In 1993, Robert Kahn and Vinton Cerf began work on TCP to develop the next generation of the ARPANET. TCP was designed to replace ARPANET's current Network Control Program or NCP. In 1978, TCP was divided into 2 protocols which are TCP and IP. Later, other protocols were added to the TCP or IP suite of protocols including Telnet, FTP, DNS, and many others. Open standards. The Network Society or ICOC, the Internet Architecture Board or IAB, the Internet Engineering Task Force or IETF, Institute of Electrical and Electronics Engineers, which is IEEE, the International Organization Standard or ISO. It is also indicated the logo of them. Other standards organization, the Electronic Industries Alliance or EIA, the Telecommunication Industries Association or TIA, the International Telecommunications Union, Telecommunication Standards Sector or ITU-T, the Internet Corporation or Assigned Names and Number ICANN, the Internet Assigned Numbers Authority or IANA. Benefits of using a layered model. A network model is only a representation of a network operation. The model is not actual network. You have seen the OSI model, also the TCP or IP model, and its TCP or IP protocol suite. The TCP or IP reference model. TCP or IP model, the first one is application. It represents data to the user plus encoding and dialogue control. Transport, it supports communication between the diverse devices across diverse networks. Internet, it determines the best path through the network, and the network access controls the hardware, device, and media that make up the network. Communicating the messages. Segmenting message benefits. It is different. Conversation can be interleaved. Increased reliability of network communications. Segmenting message disadvantage. Increased level of complexity. The picture shows the communicating the message. Protocol data units or PDUs has data, segment, packet, frame, and bits. Summary for this chapter. In this chapter, you learned data network are system of end devices, intermediary devices, and then media connecting the device. For communication to occur, these devices must know how to communicate. These devices must comply with communication rules and protocols. TCP or IP is an example of a protocol suite. Most protocols are created by standards organizations such as the IETF or IEEE. The most widely used networking models are the OSI and TCP or IP models. Data that passes down the stack of the OSI model is segmented into pieces and encapsulated with addresses and other labels. The process is reversed as the pieces are encapsulated and passed up the destination protocol stack. The OSI model describes the process of encoding, formatting, segmenting, and encapsulating data for transmission over the network. The TCP or IP protocol suite is an open standard protocol that has been endorsed by the networking industry and ratified or approved by a standard organization. The Internet Protocol Suite is a suite of protocols required for transmitting and receiving information using the Internet. Protocol data units or PDUs are named according to the protocols of TCP or IP suite, which is the data, segment, packet, frame, and bits. Applying models allows individual companies and trade associations to analyze current network and plan the network of the future. In addition, data networks are systems of end devices, intermediary devices, and the media connecting them. For communication to occur, these devices must know how to communicate. These devices must comply with communication rules and protocols. TCP or IP is an example of a standard organization such as the IETF or IEEE. The Institution of Electrical and Electronics Engineering is a professional organization for those the electrical engineering and electronic field. ISO, the International Organization for Standardization is the world's largest developer of international standards for a wide variety of products and services. The most widely used networking models are the OSI and the TCP or IP models, associating the protocols that set the rules. Models set the rules of data communication with the different layers of these models is useful in determining which devices and services are applied as specific points as data passes across the LANs and WANs. Data that passes down the stack of the OSI model is segmented into pieces and encapsulated with address and other labels.